What's up guys? Welcome back again to my YouTube channel, and for this video I will be doing the activity of chapter 6. So if you want to learn something for me, or if you want to get some information about the chapter 6, stay tuned and I'll be back guys. Hi guys, so welcome back again. So I will be doing the last chapter, or the last activities in the chapter 6. So the first activity in chapter 6, the IP characteristics. So this is the instructions. Read each IP characteristics, then click connectionless, best effort, or immediate independent indicates delivery method. So there are some characteristics, or the IP characteristics, that show below or show here in the right top corner of our screen. Then there are three types of delivery method. So the first one is the connectionless, the next one is the best effort, then the third one is the media independent. So let's start. The first IP characteristic is will adjust the size of the packet sent depending on what type of network access will be used. Well, I think it is the media independent. Then the next one rather is no contact is made with the destination host before sending a packet. No contact is made with the destination host before sending a packet. Well, I think it is it is a connection. Then the next one is fiber optics cabling, satellites, and wireless can all be used to route the same packet. Well, it is a media independent. And the next one is packet delivery is not guaranteed. Best effort, and does not guarantee that the packet will be delivered fully without errors. It is best effort too. Then the next one is will send a packet even if the destination host is not available to receive it. Oh, it's correct. I thought there are some characteristics will be shown, but there are the IP characteristic in connectionless is no contact is made with the destination host before sending a packet. Then the next one is send a packet even if the destination host is not able to receive it. Then the next one is the best effort is does not guarantee that the packet will be delivered fully without errors. Then the next one is packet delivery is not guaranteed. Then the media independent will adjust the size of the packet sent depending on what type of network access will be used. Then the next one is, or the last one is the fiber optics cabling, satellites, and wireless can all be used to route the same packet. Okay, for our next activity, the part 1 IPv4 header fields, or the IP version for header fields. So again, in our previous activity, there are some showing header function, and then we will be clicking the header field to which it belongs. Well, the first one is always set to 0100 for IPv4. Well, we will see if it's version, if it's time to leave, source IP address, differentiated service, the protocol, or the destination IP address. So the first one is always set to 0100 for IPv4. Well, I think it is the version. Then the next one is identify the IP address of the recipient host. Identifies the IP address of the recipient host. It is the source IP. Oh, incorrect. Well, this is destination IP address. Then the next one is identify the IP address of the sending host. It is the source IP address. Then the next one is commonly referred to as hop count. Well, I think it is time to leave. Oh, it's correct. And next one is identify the upper layer protocol to be used next. It is the protocol. Then the last or the next one is the identifies the priority of each packet well, differentiated service, and it's correct. So these are the functions. The first one is the version. Always set to 0100 for IPv4. Then time to leave, commonly referred to as hop count. Then the third one is source IP address, identifies the IP address of the sending host. Then the next one is differentiated services. It identifies the priority of each packet. Then the next one is protocol. It identifies the upper layer protocol to be used next. Then the last one is destination IP address. Identifies the IP address of the recipient host. Okay, in our next activity, again, same instruction or same procedure as well as activity, previous activity. So the title of our next activity is the IP version 6 header fields. So again, the instruction is read each IPv6 header description and then click the IPv6 header field to which it belongs. So the first one is when this value reaches 0, the sender is notified that the packet was not delivered. Well, I think it is the hop limit. Then the next one is to suggest that all packets receive the same type of handling by IPv6 routers. It is the flow label. Then it's always set to 0110. It is the version. Then identifies the application type to the upper layer protocol. Next header. Then identifies the size of the data portion of the packet. Well, I think it's the payload length. Then the next one is classifies packets for congestion control. It is the traffic class. Well, the first one is the version. It is always set to 0110. Then the next is the traffic class that classifies packets for congestion control. Then the flow label to suggest that all packets receive the same type of handling by IPv6 routers. Then the next one is the payload length, or they identifies the size of the data portion of the packet. Then the next header identifies the application type to the upper layer protocol, and the last one is the hop limit. And when this value reaches 0, the sender is notified that the packet was not delivered. Okay, for our next activity, the title of our activity is the identify elements of a router routing table entry. So the instruction is a partial router routing table entry is shown, and each section of the entry is identified by a circle letter above it. So select the correct routing table entry section for each output. So the first one is the elapsed time since the network was discovered. It is the letter E. Then the administrative distance, source and metric to reach the remote network, it is the letter C. Then how the network was learned by the router, of course it's letter A. Then shows the destination networks, it is letter B. Then the next hub IP address to reach the remote network is letter D. And lastly, the outgoing interface on the router to reach the destination network is letter F. So let's see if our answer is correct. And it's correct. So the elapsed time since the network was discovered is letter E. Then the administrative distance or source and metric to reach the remote network is letter C, or the 90/372 or 3072. Then how the network was learned by the router, of course, is letter A. Then shows the destination where the work shows the destination network, it is letter B. Then the next IP address to reach the remote network is letter D. And lastly, the outgoing interface on the router to reach the destination network is letter F. Okay, for our next activity, it is the descriptions of router functions and hardware parts. So instruction, descriptions of router functions and hardware parts are provided in the table. So drag each router component name to its function description. So there are 5 router component name, and we will be dragging it to its right function or description. So the first one is connects routers to external networks, usually over a large distance. So it is the WAN interface. Then a way to remotely access the CLI across a network interface, it is the telnet or the SSH. Then the third one is connects computers, switches, and routers for internal networking. It's the LAN interface. Then a local port which uses USB or low-speed serial connections to manage network devices. It is the console port. Then the last one is a port to manage routers using telephone lines and modems. It is the AUX port. So let's see if our answer is correct. And it's correct. So the WAN interface is connects routers to external networks, usually over a large distance. Then the telnet or SSH a way to remotely access the CLI across a network interface. Then the LAN interface connects computers, switches, and routers for internal networking. Then console port, a local port which uses USB or low-speed serial connections to manage network devices. Then AUX port, a port to manage routers using telephone lines and modems. Okay, so for our last activity, I will be doing the activity, the router boot process. So the instruction is drag each of the steps on the left to appropriate field in the table on the right to show the router boot process order. So the step 1, the router boot process. The step 1 is perform POST or the hardware check performed by built-in ROM chip or the ROM chip. Then the step 2 is load bootstrap copied from ROM to RAM locates the iOS. Then the next one is load the iOS operating system file for the router loaded into RAM after bootstrap finds the iOS file to be used. And the last one, or the step 4, is the load the configuration file from Flash or the NVRAM at the FTP server or go into setup mode to create a configuration file. So this is our steps in the router boot process. Okay guys, thank you for watching. I hope you learned something from me, and I hope you get some information about the chapter 6. And that's also hit the like button and the subscribe button down below. And thank you for watching guys. See you in our next video.